has worked in a project on the CERN Hadron Collider in Switzerland, which, if you know anything about physics, that is like the biggest thing ever. So we've got a top-notch person here that is so exciting, and she's also worked coordinating a project with an ion collider in. She's also going to describe the Mandela Effect, which she just explained to me. It's like, whoa, cool, and I love parallel reality stuff. It has these pyramids that emit positive energy and diminish the negative energy, and this lady knows what she's talking about, so you might want to go and get a pyramid. So please help me welcome Audrey Rumbers.
Hello, you guys.
Good.
Well, I'd like to welcome you guys to the quantum age, because whether you know it or not, that's what you're living in right now. Not in the future, not in a few years, not way when you're dead and gone. No, as you stand on this earth right now, you're living in a quantum age. Now, what is the quantum age? What am I talking about? What is this about? Okay, first of all, let me give you a little bit of my background. I worked at Wayne State for 26 years. 20 of those years I worked in the physics and astronomy department, and I worked on 2 major quantum physics international collaborations. The first one was the RIC Collider, and that was being built at Brookhaven National Laboratory, which is in Upton, New York. That was my first experience dealing with quantum physics, experimentation and research, and I really had no idea what it was. I got the job, and the first thing I asked them is, do I have to know anything about physics? Because if I have to know anything about physics, I can't do this job. And they said, nope, you're just going to be an administrator, you're just going to be, doing the paperwork. Well, it was kind of true, because I didn't have to know about physics per se, but I had to understand the terminology. It's like being a secretary in a doctor's office. Is the difference between that and being in a business office. You have to learn how doctors talk. I had to learn how quantum physicists talk, because the language was like straight over my head, even just trying to process their paperwork. Okay, so after Rick, we started a project which is called ALICE. And ALICE is a part of the Large Hadron Collider that is housed at CERN in Geneva, Switzerland. This thing is huge. It's bigger than a house. And you have these 4 major collider experiments going on. And one of those is ALICE. And ALICE stands for a Large Ion Collider Experiment. That was my project. That is the one that I was the project coordinator for Wayne State's part, because it's a huge collaboration. So everyone has their little part to do, and then it all comes together. And then we ship whatever parts you're doing to CERN, and then they put it in, and they built this thing. Now, when I first came to work for these people, I had no idea that my life was going to be changed. Totally changed. The way that I think of myself, the way I think about this world, the way I think about reality is totally different. And it's all because of what I experienced there. Now you have to understand, in my own personal time, I was into metaphysics. I like studying ancient Egypt, ancient Africa, the Chinese, all of this, because I was trying to understand, what did they do back then? And how did we get here? But the strange thing was, my personal studies and research into ancient things and my work with futuristic things were coming together. And I'm a kind of person that I tend to recognize patterns of things. Things that most people may not, recognize. Like when I was little, I noticed that a car looked like a person. I'm like, it got a face. It got 2 eyes. It looks like me. You know what I'm saying? So I'm like, wow. So, even though they look different, I could see the similarities in them. So this was what was happening when I was studying metaphysics, and my job was talking about this futuristic stuff and these just unbelievable concepts. And so it got to the point where I went into my boss's office, and this is a very serious man, so you don't just go in there, saying anything. But I'm like, Tom, wait, because I'm like getting a little freaked out here, because I'm trying to understand what's happening here. And I said, well, these same concepts that you're talking about in quantum physics, this sounded kind of similar to what I'm, studying in this ancient Egypt and ancient African cosmologies and spirituality. And the first thing he said to me was, well, that can't be true because quantum physics wasn't discovered until the 1930s. And I said, well, I don't care when quantum physics was discovered. These two things are still sounding very similar. And then he said, well, you know what they say, there's nothing new under the sun. Okay, good, okay, I'm all right, so I'm not crazy because you're right. And then as we were we were going on with this, and I'm kind of trying to understand what the heck are we doing here? Then I started realizing that, wait a minute, what these things that these quantum physicists are talking about, it sounds like magic. Magic? Yeah, that can't be right. My boss is off again, Tom. Wait a minute now, because, I don't know physics and all of this, but I'm trying to understand this. And I said, well, if I understand correctly what you're doing, if we get a hold of this, if we get an understanding of this, then we will be able to do magic. And I use the word magic with a quantum physicist because I know you go that far, they're going to like, no, come on, get a little ridiculous with it. And he turned to me and he just said, yes. Yes. Not with a yes and a but, just yes. And at that point, I became obsessed. Everything I could read, every book. I think the first video I got was What the Bleep Do We Know? And it gave me this perspective. But what I didn't realize, the synchronicity was happening already. Because What the Bleep is about Alice going down the rabbit hole. And it just hit me that my project is Alice. Oh my God! And I'm going down the rabbit hole. How did this? And I didn't even make the connection for a while, And then when I noticed things like, what's his name? Brown. Oh my gosh. He wrote the book Angels and Demons.
Dan Brown.
Dan Brown. Wait a minute. He's talking about CERN. I know CERN. He's talking about colliders. I know colliders. Wait a minute. So all of these things started to alert me to what I was dealing with. It was something much larger than I thought. So that's how I got into it, and that's how I started making my pyramids, because once I started understanding about these invisible energies and how we can tap into these things, I'm the kind of person that feels that if it's true, I want to try it out. I want to see if it works. Either it works or it doesn't, but I want to try it out because I want to be empowered like that. So I started to study fiber optics, because fiber optics are used in all of these quantum experiments. And if you've ever seen a fiber optic strand, it's a thin strand of plastic, and it's lit at both ends. What? And I was surprised about that. I'm like, what is this thing? And how is it lit? There's nothing, so of course I go to them. What is this? I'm just naturally nosy. I'm always sticking my nose in things that most people would just ignore. But I'm curious, what is this thing? I'm purchasing them. I understand, but I don't understand what they're about. So then they explained to me that what it is about fiber optics is that fiber optics, instead of, most things reflect light, with fiber optics, the light travels through them. You see, and there's energy signals that travel on that light beam that's coming through. And I'm like, wait a minute. So I started thinking about, well, how is this energy? Just studying the transfer of invisible energies. How do we do this? And then, as synchronicity would have it, I ended up hiring an assistant who was into crystals. She sold crystals. I'm like, I've always been interested in it. So she went to telling me about the energies of crystals. And she brought in this big box of crystals and was telling me what they were and what they did. And I'm like, really? I'm just like, wow, that's fascinating. So basically from that, I just studied, and I just saw this, once again, this pattern between the energy that's given off by crystals, especially quartz crystals. And I don't know how many of you know this, but quartz crystals in all of your electronics. All of your electronics works on quartz crystals. And I was like, what? Why is quartz crystals in my electronics? So then I understood that quartz crystals give off an energy called Piezo Electricity once it's under pressure. So I got introduced to Wilhelm Reich, who was the originator of Audranite. And he was talking about these same invisible tapping into these energies, kind of like what they're talking about. So I started making Audranite, which I call Wilhelm Reich's Audranite. I call it analog Audranite. And I call what I make digital Audranite. Because analog Audranite deals with heavy metals, layering of heavy metals. Digital Audranite deals with light, sending the signals by light. And that's something I learned from working with the quantum physicists. So that's the part of me now, because I want to get to the real purpose that I really want to get to. So what I'm going to do right now is I'm going to kind of just give you a quick overview of what quantum physics is. Quantum physics sounds like a real, serious kind of subject. Quantum physics. It scared me for many years. But after I started thinking about what is it really, because for me, it's easier for me to bring things down to its lowest level of understanding and then build it up. So treat me like a child. If you're going to explain it to a child, how would you explain quantum physics? How would I explain quantum physics? Right? Yeah. So when I took quantum physics down to its most fundamental definition, basically quantum physics is simply the study of very, 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 very small things. That's it. That's what you're doing? Small things? Now here's the thing with quantum physics is that when you start studying those very, 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 very small things, things get weird. Really weird. The laws of physics totally break down. Totally break down. Now when I understood this, I'm like, wait a minute. When you're talking about the study of small things in actuality, you're talking about the study of me. I'm made of atoms. I'm made of protons, neutrons, electrons. So you're talking about me. So that weird thing that's going on at that level, that's me. You're not talking about, you see, because when I first came into the department, quantum physics was way down there. I could see it, but I'm not. But the more I started to study it, just kind of closer and closer until it's like, oh my God, you're talking about me. So of course that's going to make me really get interested in what is going on. So now what I'm going to do is I'm going to give you the definition from Wikipedia of what the Large Hadron Collider is. Now before I go into that, let me tell you that the Large Hadron Collider is colliding hadrons. Hadrons are the things that make up protons and neutrons. In the nucleus, and you have that force that keeps them together. Well, so what these scientists were doing is they said, okay, we want to know what is all of this made of. So what they're doing, trying to go and find the smallest particle of matter that everything is made up of. And so they keep getting smaller. So we read atoms, so okay, we break that up, we see what that's made of. Okay, the atoms are made of electrons, neutrons, and protons. Okay, well what are those made of? And how they determine what they're made of is they created this large machine, which is the Large Hadron Collider. Now, Wikipedia says, the Large Hadron Collider is the world's largest and most powerful particle collider and the largest machine in the world. It was built by the European Organization for Nuclear Research, which is CERN, between 1998 and 2008 in collaboration with over 10,000 scientists and hundreds of universities, laboratories, as well as more than 100 countries. It lies in a tunnel, 17 miles in circumference, and as deep as 574 feet beneath the surface of the earth. 17 miles in circumference, 574 feet beneath the earth. What are we doing? Beneath. And what it is that, and it's really weird because you have to take this humongous machine to deal with the smallest particles. And what they did is that they took these particles, like Alice took lead iron, and they speed them up. And that 17 miles of compass is those little particles in a vacuum. They send them shooting around. That's the collider, that's the collision. When you collide things together, they break apart. When they break apart, then you can see, oh, what is that made of? So that's what they're doing. Now, most of us know that when you're doing experimentation with atoms and things of that nature, you don't actually see the atom. You just don't see it. It's just too small. But what you do see is the aftermath of the collision. And you kind of work yourself back. What is this? What came from this? So when they smashed protons and they broke them apart, they found a smaller particle, and that's called quarks, gluons, and these things. Strange lists. They have weird names for them, So these things are happening. But like I said, when they go down to that small of a particle, it gets strange. Now, what do I mean by it gets strange? Well, there are two concepts in quantum physics that pretty much started this whole thing. One of the concepts is called quantum superposition. What is superposition? Superposition. Superposition means that a particle can be everywhere at the same time. There's another concept they call quantum entanglement. Quantum entanglement says that we're all connected on a quantum level. There's something that's attaching all of us to each other, whether we see it or not. It's there, they see it. So, in order, how they found out about quantum superposition is this very, very special, it is a special experiment. It's called the double slit experiment. This experiment pretty much created the study of quantum physics. Now, what's the double slit experiment? Simply, double slit experiment was this. Scientists said, okay, we got these little small particles. Let's call them, let's say, photons, particles of matter. And they sent it through a slit, one slit. When they sent it through a slit, they moved it, and you go on the backboard, as if I was sending a proton to that back wall. And I'm shooting them through a slit. When I shoot them through the slit, they're all going to wind up in between the slit, because that's where I shot them through. Well, when they put two slits down there and they shot these small particles through them, you would expect them to make two lines, because you're going through two slits. But it didn't happen. What actually happened was they created what's called an interference pattern, like a wave. Instead of two lines like this, they have lines like this. What? How's that possible? We got two slits. We sending these particles through two slits. I should make two lines. What is this interference pattern? What is all of this? Like I'm sending a wave through it. Couldn't understand it. So the scientist said, okay, here's what we're going to do. We're going to shoot one particle at a time so we can see exactly where it goes. So that's what they did. But after a certain amount of time, guess what? Even when they just shot one particle at a time, they still ended up with an interference pattern. What is that about? How is that possible? You send them through two slits. Their matter, they should come out two slits. So the scientist said, okay, here's what we're going to do. We're going to watch it. How are we going to watch it? We're going to measure it. We're going to put our measuring stuff up here, and we're going to watch every single one of those little particles. And when they did that, guess what happened? It made two lines. It's as if the particle knew they were watching and decided to be what you thought it was. What? How is this possible? So basically what they determined is that at the quantum level, it's not matter, it's possibilities. Waves of possibilities. Every possibility that can be conceived is living down at this quantum level. And when we make a decision, whether it's to get up at 5 instead of 6, and it's to go to the restroom instead of go to the kitchen, it's like, okay, all the possibility turns into a fact. And it's called the collapse of the wave function. Okay, you made a decision. You got all of these possible decisions you made. You made it, it collapsed. You made another one, it collapsed. You made another one, it collapsed. But what's weird is every possibility that there can be is happening. In another, and that's what we're going to get into DWave to say, in another reality. And just like you were saying, the guy said, Stephen Hawking told him, don't worry about it. In another reality, those things have happened. Because every possible thing that can happen is happening, period. Okay? So, superposition, Einstein called it spooky action at a distance. It was weird, okay? So, all right. So, when I think about quantum physics, I said to myself, okay, I'm trying to understand this on a fundamental level. And then I said, oh, two things at the same time. How is that possible? Then I realized, well, we're all two things at the same time, all the time. And how is that possible? I said, well, okay, here I am, this size, right? This is my size. If I look down, let's say at an ant, all of a sudden I'm gigantic. I'm humongous. I'm like a god. I'm so huge. And if I go down even further and I look at the atom, if I compare myself to the atom, I'm even going further. So here's the thing. The further I look down this way, the huger I become without moving. But I'm still getting bigger. I keep looking down. The further I look down. Now, if I stop looking down and I look up, holy crap. I've just turned as small as a nanoparticle. And I haven't moved. It's just my perspective has changed. So when I said, oh, okay, well, maybe in some way, this can make sense because I can see it in that way. And I'm just standing here and I'm getting big, small, however, it's happening right now. So I'm like, okay, so I think I'm getting this. And then also, I started thinking about things like when I was younger and I learned about the placebo effect. You guys know what the placebo effect is?
Yep.
Strange. The placebo effect says that you can give someone who's actually sick, you can give them a sugar pill. And as long as they think that they're getting medicine, their bodies will react to that sugar pill as if you gave them actual medicine. That made no sense to me. I don't understand. Either you're sick or you're not sick. How is it that just by thinking something, I can change physical reality? And it's the same way in what we used to call psychosomatic illnesses. Another thing, how can I think myself sick? Either I'm sick, either the germs come in or the germs don't. But yet you're telling me that some people can actually think themselves sick. You see, so because of these concepts, the things that they were telling me about quantum physics didn't sound so crazy, because I had something to pretty based on that concept on, because you can't explain to me psychosomatic illnesses, you can't explain to me why the placebo effect works, but it does. So, therefore, I started to really think, well, there was a possibility that what these things they were saying was true. So, like I said, remember, when we're talking about these things, we're talking about us. We're talking about us as humans. This thing that we're made up of. Okay. So,